During this presentation, I will be discussing a fundamental topic to technology: operating systems and firewalls. These two components are crucial in managing and securing computing environments. During this presentation, I will discuss what they are, their roles, and some specific examples including Microsoft Server 2022 and Ubuntu Server 24, as well as Windows Firewall and IP tables. An operating system, or OS, is the software backbone of a computer, managing hardware and software resources. It acts as a bridge between the user and the computer's hardware. This allows users to perform tasks without needing to understand complex machine-level languages. Common examples include Microsoft Windows and Mac OS. The role of an operating system extends beyond mere interaction facilitation. It manages files, controls hardware like memory and processors, and ensures efficient execution of applications. Without an operating system, our interactions with computers would be difficult and restricted to very technical users. Now, let's dive into a specific OS designed for more advanced needs: Microsoft Server 2022. This operating system is tailored for servers, which are powerful computers that manage network resources and store data for other computers. Microsoft Server 2022 incorporates multi-layer security features to protect against cyber threats and firmware attacks. One of its standout features is the ability to support secure connections through SMB over QUIC, which enhances remote file access security without requiring a VPN. This feature is particularly useful in the modern era of remote work, where secure and efficient access to resources is important. Another significant aspect of Microsoft Server 2022 is the integration with Azure services. This enables hybrid capabilities, allowing businesses to seamlessly manage on-premises and cloud resources. This hybrid model is increasingly adopted by organizations aiming for flexible and scalable IT infrastructure. For optimal use of Microsoft Server 2022, there are a few key practices I would recommend. First, creating advanced firewall rules tailored to specific network traffic needs can help enhance security. Utilizing secure core server features will protect against firmware threats, adding another layer of defense. Configuring Windows Defender Application Control, or WDAC, ensures regular scans and updates while providing robust protection against malware. Keeping the server updated with the latest security patches is crucial for defending against new vulnerabilities and exploits. Another powerful server OS is Ubuntu Server 24. Unlike typical desktop operating systems, Ubuntu Server focuses heavily on security and performance for critical data handling. Ubuntu Server 24 enhances application security with AppArmor profiles, which offer control over application permissions. This feature is particularly important in environments handling sensitive or classified data, as it minimizes the risk of unauthorized access. Kernel security has also been improved in this version. It helps prevent programming attacks. In addition, Ubuntu Server 24 enforces more secure TLS protocols by disabling outdated versions. This ensures secure communications over the network, protecting data in transit from potential threats. To ensure Ubuntu Server 24 remains secure and efficient, it's important to follow certain best practices. Regular patch management is crucial for protecting against newly discovered vulnerabilities. This involves routinely updating the OS to include the latest security fixes. Using SSH key authentication significantly reduces the risk of brute force attacks. Additionally, disabling root login over SSH adds another layer of security by limiting direct access to the server's administrative functions. Enabling the Uncomplicated Firewall, or UFW, allows you to control traffic more effectively by limiting access to essential services only. This practice minimizes exposure to potential attacks and ensures that only necessary traffic is allowed. A firewall is a crucial security component in any network. It acts as a barrier between a trusted internal network and an untrusted external network, such as the Internet. Firewalls manage and regulate incoming and outgoing network traffic based on predetermined security rules. The primary purpose of a firewall is to prevent unauthorized access to or from a private network. Firewalls can be hardware-based or software-based, and they operate by examining packets of data and deciding whether to allow or block them based on established security rules. Examples include proxy firewalls and next-generation firewalls, or NGFW. Proxy firewalls act as a gateway from one network to another for a specific application. Next-generation firewalls have abilities beyond a traditional firewall. They include features such as application awareness and control, threat intelligence, intrusion prevention systems, and URL filtering. An example of a software-based firewall is Windows Firewall. This built-in tool in Windows operating system helps protect systems by filtering incoming and outgoing network traffic. It allows or blocks connections based on rules that the user or administrator can define. Windows Firewall provides logging capabilities, enabling administrators to monitor and track network activity. This feature is invaluable for conducting security audits and detecting suspicious activities. The firewall also integrates with IPsec, supporting secure communication through encryption and authentication. To ensure Windows Firewall operates effectively, it's essential to regularly review and update its rules. Security policies evolve, and outdated rules can leave the system vulnerable. Employing dynamic keywords for DNS and other services can help maintain accurate and efficient network communication. Activating firewall logging is another crucial step. By monitoring network traffic, you can quickly detect and respond to potential security threats, ensuring the system remains protected. IP tables are a firewall used in Linux environments. IP tables work by comparing network traffic against a set of rules defined by the user. It organizes these rules into tables such as filter, NAT, and mingle, and uses predefined chains like input, output, and forward to process packets. The flexibility of IP tables allows users to create complex rule sets tailored to their specific network requirements. This enables precise control over traffic, ensuring that only authorized data flows through the network. For effective use of IP tables, it's advisable to implement default policies that drop incoming traffic unless explicitly allowed by specific rules. This approach minimizes exposure to potential threats by only allowing necessary services. Ensuring that firewall rules are saved and consistent across reboots is critical for maintaining a secure environment. Regularly reviewing and updating the rules ensures they remain aligned with current security needs and best practices.